Bristol Community College, Mathematics with Dan Avedikian, Math 131, Elements of College Mathematics, Section 5.2, Problem 5. So this is Section 5.2, Problem 5. It says, Linda's brother Bob starts saving for retirement when he is 48. He saves $480 every month at 12% compounded monthly. How much will Bob have by the time he's 65? And then it asks, when will you start? Like, when will you start saving? Because problem 4 had Bob's sister, Linda, who was saving only $40 a week. Very small amount. $40 a month. $40 a month isn't much. It's a little more than $1 a day. Bob is saving a lot more, $480 a month, more than 10 times as much. But he's doing it for fewer years. See, Linda started when she was 21, if you remember the previous problem. Bob's starting a little later, 48, but he's saving a lot more, so you'll see who comes out ahead. So let's find out. So if you remember, Linda got a little more than $700,000, $761,000, because she started very young and saved only a little bit. Bob is starting later and he saves a lot. So we start with the formula. A equals P times, in brackets we have 1 plus R over M to the M times T power, and then there's a minus 1 over that in the numerator of the brackets, and R over M in the denominator of the brackets. So A equals P is the regular savings, which for this problem is $480. And now times some brackets, and in the numerator of the brackets we're going to have in parentheses 1 plus R over M. R is the rate as a decimal, so our rate is 12%. As a decimal, that's 0.12, and it's over M. M is the number of times compounded per year. So if we're compounding monthly, that would make M 12, because there are 12 months in a year. I close my parentheses. I have an exponent of M times T. M again is 12 for monthly compounding. Now T, the number of years, is going to be 17, because Bob starts at age 48, and for 17 more years he saves, and that'll take him to age 65. So 48 plus 17 is 65. So that's the value for T, the number of years. And after my parentheses I have a minus 1. In the denominator of my brackets, R over M again. So again, R, the rate as a decimal, is 12%. And M, number of times compounded per year, is 12. I close up my brackets. And that's how the formula fills in. Now I'll start the computation. And as usual, I have to start in the parentheses. And I can simplify a few other things as I do the parentheses. So at that point, I'm going to have A equals $480 times, and then I have in brackets, there's a numerator and a denominator. In the numerator, the 1 plus 0.12 over 12. The 0.12 over 12 is 0.01. And I'm going to add 1 to that. So 0.01 plus 1 is 1.01. That's in parentheses. And it's going to have an exponent of 12 times 17. 12 times 17 is 204. And I'm figuring 10 17s is 170, and then 2 more 17s is 34. So when you combine the two, 170 and 34 more is 204. There's a minus 1. And then in the denominator, 0.12 over 12, again, is 0.01. And I'll close up the brackets. And the next part of the process, I have to do the exponent of 1.01 to the 204th power. So as I do that, I'm going to have A equals 480 times some brackets. The brackets will have a numerator and a denominator. And in the numerator, I'm going to have some big number that I get from 1.01 to the 204th power. Whatever that answer is, there'll be a minus 1 after it. And in the denominator of the brackets, a 0.01 still. So let's figure out what I get for 1.01 to the 204th power. So 1.01, I put that on the screen first, press the exponent button on the calculator, 204 for an exponent equals, and I get 17.613077514. So now I have A equals 480 times in brackets, on the top of the bracket, 7.613077514 minus 1. And in the denominator of the brackets, 0.01. So let me do the minus 1. That'll give me A equals 480 times the brackets. Still now, the numerator of the brackets has 6.613077514. Again, I let all the decimals run until the very last step, then I round it off. There's a 0.01 in the denominator of the brackets. So now to finish the brackets off, I can divide 6.613077514 divided by 0.01. That'll give me 480 times, in the brackets that have one value, it'll be 661.30777514. And to finish it off, I'll do 480 times the number in the brackets, the 661 times something. So let's see what I get when I do that. Times 480 gives me A equals 317.7207. Now again, that's my answer. I want to round it so that it has two places after the decimal. It's going to, because it's in terms of money. 0.720 something is not enough to make it 73 cents. So my final answer, let's just put it in red in this area just to make it stand out a little bit, will be $317,427.73. So now that's an interesting comparison, because Linda, Bob's sister from the previous problem, starts at age 21 and saves only $40 a month, same interest rate, and winds up with double, a little more. She had $761,000. Bob starts later but saves much, much more money, but that head start really gives Linda a big advantage. So that's why at the end of the question I put, when will you start? When will you start saving? So if you start early, you don't need nearly as much. $40 versus $480, and the 40 wins by a lot.